Hi, my name is Sharunas. I'm VP of 3D at CGTrader for almost 8 years and over 17-year experience in 3D. Today I will talk about model quality and why it's essential. Creating a good-looking 3D model is important, but making sure they're technically correct is just as crucial. A model that looks amazing but isn't built properly can cause problems in rendering, slow down projects, or even crash your software. At CGTrader, we know that technical quality saves time, cuts costs, and helps models fit smoothly into professional pipelines. That's why in this video we'll walk you through the most important technical tips to get your models ready for production, whether you're building for games, animation, VR, or anything else. We'll cover key things like clean geometry, proper texturing, organized files, and more. These basics make your models easier to use and more attractive to buyers. When preparing a model for publishing, we encourage everyone to use Kodama, our free plugin for 3ds Max and Blender. Kodama automatically checks your models for common issues like flip, normals, bad topology, or extra vertices. It helps you fix problems early so you can focus on creating, not troubleshooting. Let's jump in and see what it takes to make your models not only look great, but work great as well. Alright, let's start with the basics, the file format. Choosing the right one might seem small, but it has big impact. The wrong format can lead to bloated files, bugs, or headaches down the line. For most professional 3D work, we recommend using FBX. It's reliable, widely supported, and packs everything you need: geometry, materials, UVs, animation, rigging, even cameras and lights, all in one place. FBX works well across popular software like Blender, 3ds Max, Maya, Unity, and Unreal. So by using FBX, you are making sure your model stays consistent and plays nicely across different tools and pipelines. It's a simple step, but a smart one that helps you avoid problems later. When exporting FBX file, make sure it's set to binary format. In the export window, navigate to FBX file format tab. Under type, select binary to ensure compatibility with most 3D applications. Now that your file is set, let's look at the scene setup. A messy scene with extra lights, cameras, or dummy objects can be a real pain, not just for you, but for anyone using your model later. Keep it clean, only include what's needed. This makes your files easy to work with, helps avoid errors, and keeps everything running smoothly in production. Blender does not support ASCII FBX files. This means that all FBX files exported from Blender are in binary format. There are two ways to exclude unsupported objects when exporting an FBX file. The first method is to remove them from the scene before exporting. To do this, open the Select menu, go to Select All by Type, and choose Lights or Camera. This will highlight unsupported objects. Once selected, simply delete them. The second method is to exclude them during export. In the FBX export window, hold Shift, then uncheck Camera and Light under Object Types. To ensure that only geometry is exported, follow these steps. If there's a single geometry object, simply left-click on the viewport and select it. For multiple geometry objects, open Scene Explorer or Layer Explorer, hold Alt and click on sphere icon to hide all non-geometry objects. Then select all remaining geometry objects. Once the geometry is selected, go to the File menu and choose Export Selected. Select your desired file location and export FBX file. With your scene cleaned up, let's move on to core of your model, the geometry. Good geometry isn't just about looks. It affects performance, rendering, and how easy the model is to work with later. Clean, optimized geometry makes your model faster, smoother, and more reliable. So let's go over key tips for building solid geometry in Blender and 3ds Max. To ensure clean topology, we need to eliminate n-gons from your model. Here's how to find them and fix them. First, select your object and switch from Object mode to Edit mode. Now open Select menu, go to Select All by Trait, and choose Faces by Sides. In the bottom left corner of the viewport, expand Settings window. Set type to greater than and the number of vertices to 4. This will highlight all n-gons in your model. Once selected, you have two options: fix them manually or automatically. For the manual fix, use the knife tool from Tool Panel or press K on your keyboard. Make a cut from one vertex to another, converting the n-gon into quads or triangles. For precise cuts, enable vertex snapping, located in the center of the top bar. For an automatic fix, with n-gon still selected, open Face menu and choose Triangulate Faces, or simply press Ctrl-T. And that's it. By following these steps, you can maintain clean, efficient geometry in your 3D models. To ensure smooth appearance, the model should not be fully faceted. First, select Faceted Object, then right-click in the viewport and choose Shade Smooth for an even surface. If needed, you can use Shade Smooth by Angle to control smoothing effect based on the object's geometry. To ensure your model is properly structured, we need to fix any non-manifold geometry. Here's how to do it. First, select the object and switch from Object Mode to Edit Mode. Use Vertex or Edge Selection Mode, then open Select menu, go to Select All by Trait, and choose Non-Manifold. In the bottom left corner of the viewport, expand the Settings window and uncheck Boundaries, since open edges are not allowed. Now that the non-manifold geometry is highlighted, let's go over how to fix it. If the issue is loose geometry, it should be removed. Open Option in the Merge by Distance or Delete Overlapping Vertices. Select non-manifold vertices and go to Mesh, Cleanup, Merge by Distance. Another option is to delete loose, found under Mesh, Cleanup. Non-manifold edges should be selected. Make sure the non-manifold geometry is selected before applying these fixes. If you have T-type non-manifold faces, where faces share the edge with another, you can fix it in two ways. Use Face Selection Mode, select the face, press Delete, and choose Faces. Or separate the face by selecting it, then go to Mesh, Split, Selection. To display flipped normals, enable Face Orientation. If the issue is flipped normals, select the entire model by pressing A or manually select affected faces. Then press Shift-N to recalculate normals. If needed, you can flip normals manually by going to Mesh, Normals, Flip. To identify n-gons, select your object and press 4 key to enter polygon selection mode. Next, open Graphite Modeling Tools panel, go to the selection menu and choose by number. Set size to 4, choose greater than to highlight all n-gons. Once n-gons are selected, you can fix them manually or automatically. To manually fix, press 1 to switch to vertex selection mode. Use the Cut tool to create edges between vertices, converting n-gons into quads or triangles. For better accuracy, enable vertex snapping. Right-click the snapping tool, select vertex in the options, and activate it by pressing S. For automatic fix, apply the Turn to Poly modifier. Set the limit polygon size to 4 to automatically convert n-gons into quads where possible. Check Keep Polygons Convex checkbox. Now your model is clean and optimized for better performance in rendering and game engines. To smooth out your model, there are a few methods you can use to apply smoothing groups. Select your model and apply Smooth modifier. If the model has polygons that share same edge, but the angle between them is close to 90 degrees, those polygons should have different smoothing groups. To achieve this, check the Auto Smooth checkbox and adjust the threshold value closer to 90 degrees. If the angle is too sharp, the polygons will be assigned separate smoothing groups. Otherwise, a single smoothing group will be applied to the entire model. Select your model and enter Editable Poly mode. Press 4 to switch to Polygon Selection mode. Go to the Polygon Smoothing Groups tab. The process works the same as the Smooth modifier, but here you can assign smoothing groups manually to each polygon. Simply select polygon and then click on the Smoothing Group ID button to assign the group. With these options, you can easily remove faceted geometry and create smooth surfaces for better rendering and presentation. Fix non-manifold geometry. Start by converting the object from an editable mesh to editable poly. This automatically converts T-type non-manifold geometry and detaches any non-manifold polygons. To identify and remove loose geometry, switch to vertex selection mode in the selection rollout. Use binumeric, set type to equal, and the edge count to 0. This selects all loose vertices. Press delete key to remove them. To display flip normals in the viewport, click on plus and go to X view, face orientation. To fix them, convert the object back to editable mesh. Apply the normal modifier from the modifier stack and check Unify Normals option. The model is now cleaned and ready for further editing. Once your geometry is clean, it's time to bring it to life with textures and materials. But it's not just about making it look good, it's about doing it right so your model works well everywhere. Using proper texture size, formats, and consistent materials helps your model look great and run smoothly across different software and renderers. Let's look at how to set this up the right way. When exporting an FBX file, make sure that embedded textures is disabled to keep textures separate from the model file. Simply uncheck the embedded textures option in the FBX export settings before exporting. To ensure that textures can be applied correctly, make sure all 3D objects in the scene have assigned materials. Open the Material Properties panel. If the material list is empty, click New to create new material. Finally, give a material clear and descriptive name for better organization. When exporting FBX file, make sure that textures are not embedded. In the Export window, go to Embed Media tab. Uncheck the Embed Media checkbox to keep textures separate from FBX file. This ensures better file management and prevents unnecessary file size increases. To ensure all 3D objects in the scene have assigned materials, follow these steps. First, open Scene Explorer by pressing H or navigating to Tools, Scene Explorer. By default, materials are not displayed in the Scene Explorer. To enable them, go to Customize, Configure Columns, then select Material. Now check Material column. If an object has a material assigned, its name will appear in this column. If the field is blank, object does not have material. To assign material, open Material Editor by pressing M, right-click inside the Material Editor window and go to Materials, General. Then select Physical Material or PBR material. Give the material a proper name. Select the object you want to apply the material to. Right-click on the material and choose Assign Material to Selection. With these steps, you ensure that all your models have proper materials assigned. Keep your scene well organized and ready for export and rendering. Good textures need good UVs. If your UVs are messy or overlapping, textures won't look right. They might stretch, break, or just not show up properly. A clean, well-unwrapped UV map makes texturing easy and keeps your model looking sharp. Let's go over what makes a solid UV layout and how to get it right. To check for overlapping UVs, start by selecting your object and switching from Object Mode to Edit Mode. Next, change the editor type from 3D Viewport to UV Editor. To check for overlapping UVs, start by splitting the viewport in two parts, one for 3D space and the other for UV Editor. In the new viewport, switch from 3D Viewport to UV Editor. Next, select your object, switch to Edit Mode. Open the Select menu and choose Select Overlap. This will highlight any overlapping UV polygons. To fix these overlaps, you can manually adjust UV vertices, edges, or polygons. Press G to move them and reposition as needed. Another option is to unwrap UV again. Switch to Face Selection mode, select a face from UV island with overlapping polygons, then go to Select menu, under Select Linked, choose Linked, or simply Ctrl L. With the entire UV island selected, go to UV menu and choose Unwrap to generate new UV layout. Properly unwrap your model, start by splitting the viewport in two parts, one for 3D space and one for UV Editor. In the new viewport, switch from 3D viewport to UV editor. Next, select your object, switch to edit mode, and set the selection mode to edge. By default, Blender only shows UVs for selected faces. If you want to see the UVs for entire object, click the UV Sync Selection button at the top left corner of the UV editor. Now use Alt plus left click to select entire edge loops, or Shift Ctrl left click to select an edge between two selected edges. With the necessary edges or edge loop selected, right click and choose Mark Seam. Repeat this process for all needed UV seams. If you're working with a low poly model with baked normal maps, make sure to add seams along sharp edges for better results. Once all seams are marked, press A to select everything. Then open UV menu and select Unwrap. That's it. Your model is now UV unwrapped and ready for texturing. To ensure there are no UV overlaps in your model, start by selecting the object and applying the Unwrap UV modifier from modifier list. Next, click Open UV Editor to access UV layout. Switch to UV polygon selection mode by clicking the rectangle icon in the bottom left corner or pressing Free. From the Select menu, choose Select Overlapped Polygons. This will highlight any areas where UVs are overlapping. To fix overlaps, you can manually move the UV vertices, edges, or polygons. Activate the Move tool by pressing W, then reposition UVs as needed. Another option is to relax the overlapping UVs. With polygons still selected, go to the Tools menu and select Relax. Uncheck the box border intersections and triangle flip for better results. If the UV islands become distorted during the relax process, try selecting the entire UV island instead. Enable Select by Element UV toggle. That's a cube icon in the bottom left corner. Then click the island and repeat the relax operation. These steps will help you clean your UVs and eliminate overlaps for clean, export-ready results. To unwrap your model UVs properly, start by selecting the object and applying Unwrap UVW modifier from the modifier list. Switch to Edge Selection mode by pressing 2. Now begin making the edges that will become your UV seams. You can select them individually by left-clicking, or quickly select an entire loop by double-clicking an edge. To select a series of edges between 2 points, use a point-to-point edge selection tool. Just click your starting edge, then ending edge, and right-click to confirm the selection. Once all desired edges are selected, convert them to seams by choosing Convert Edge Selection to Seams. Now open UV Editor and use Quick Peel to unwrap your UVs based on the seams you've defined. This method gives you clean and efficient UV layout ready for texturing. Last but not least, naming. It might feel like a small thing, but clear, consistent names for your objects, materials, and textures can save a lot of time and confusion. Good naming keeps things organized, especially when working in teams or switching between software. Let's look how to name things properly so your files stay clean and easy to use. To ensure compatibility and avoid errors, make sure that your model object, material, and texture names contain only letters, numbers, hyphens, and underscores. Any other characters are not allowed. You can easily check and edit the names in Outliner, where all the objects and materials are listed. Review all names and update them if necessary to ensure they follow the allowed naming conventions. This helps maintain clean and organized project, preventing issues during export and rendering. To ensure compatibility and avoid errors, make sure that model, object, material, and texture names contain only letters, numbers, hyphens, and underscores. Any other character are not allowed. To check object and material names, open Scene Explorer by pressing H. By default, material names are not displayed in the Scene Explorer. To enable them, go to Customize, Configure Columns, then select Material. Review all material names and update them if necessary to ensure they follow allowed naming conventions. This helps maintain clean and organized project, preventing issues during export and rendering. To update material name, open Material Editor by pressing M. With the selected object, go to Material, pick from Selected. Double-click the material to open its properties and rename it. And that's it! Now you've got the key steps for making 3D models that are clean, efficient, and production-ready. By following these steps, you'll avoid common issues like rendering glitches, slow performance, or software crashes, and save yourself a lot of time. A solid technical setup means your models will work smoothly across different tools, whether it's for games, animation, VR, or anything else. At CGTrader, we are here to help you create models that meet professional standards and stand out in any workflow. Thanks for watching. If you find this helpful, give us a like and subscribe for more modeling tips, best practices, and insights from CGTrader team. See you next time.